All right, so we're going to continue with the matrices topic and see how these homework questions look. All right, kickstart the thing. So the first question I'll be looking at looks something like this here. So it is saying use inverse matrices to solve these simultaneous equations, right? So we're going to just put that for short. All right. So the first one is 4x minus y equal minus 1 minus 2x plus 3y. You guys hear my lower up there, right? Equal 8. So, all right, so this I'm going to have to manage the space properly. So let me just put it to the side then. All right, probably put it below. Let me say it work out. So so all of these things, you try and put the coefficients of the variables in a matrix itself. So as a reminder, coefficient just mean a constant beside the variable. So the 4 here would be the coefficient, the minus 2, the 7 minus 1, 3. So the coefficients of the variable you put in a matrix by itself. So it's a 4. Because effectively, this is what you want to solve, right? This is what you're trying to do. So this is the matrix representation of this simultaneous equation. And all you're trying to do is to find the inverse, this matrix right here. So when you pre-apply it to both sides, this will become, this section will have the identity matrix, and then the result would come over here. So we need to do the task of finding the inverse. And if you recall from last week's class, inverse is given by this, where we say, okay, it's 1 over the determinant multiplied by the adjoint. And we went through everything in that lesson, right? We said the determinant is just so if this is a matrix, is the difference between the products of this diagonal and this diagonal. So the product of this diagonal minus the product of that diagonal. And then the adjoint now is swap the places of the leading diagonal, this diagonal, put 3 where you have 2, and then put minus signs, you apply minus signs to the other diagonal. So in this case, a minus sign was already here. But when you apply the minus sign, minus, give you a positive 1. And then you would have the minus 4 here. And just like that, you would get the inverse. And as you can see, in this case, the determinant is 10, 1 over 10. And this is like the scalar factor outside of the matrix. And we saw that we can just multiply each element of the matrix to then use in the final inverse matrix to apply, right? So is a similar thing. So right here, we want to find the determinant. So we can say, let's call this, I don't know, I guess I can just call it matrix A. Let me just call it matrix A for the time being. So the determinant of A, so that times that, so 4 times 3 minus, so we have minus 1 times minus 2. So I have 12. And we have quite a few minuses here, right? So this by itself, these two will give you a positive 2, but because they have a minus here, you get a negative 2. So we'll get 10. Cool. Next up, we need to look at the adjoint. So as I say, I'm calling this matrix A. So let's call this A and done, right? So you want the adjoint of A. So the adjoint of A is just switching the place of this, I call it leading diagonal, this here. Switching the place, and then apply minus signs to the other diagonal, right? So negative and negative is positive. So just like that, you get the adjoint. So the final thing, the inverse of A, right? Let me see if I can divide. I can divide this. All right, not the best division, but we work with it. So the inverse of A is 1 over the determinant, which is 1 over 10, this case. All right, let me just fix that up because that 10 looks suspect. And then we'll have multiply by the adjoint. And then, as we said before, we can just multiply each element by 1 over 10. So 1 over 10. So it's a 3 over 10, 1 over 10, and then this is 2 over 10, 4 over 10. And as I said before, avoid simplifying these things, right? Because you don't know. Usually they set the question that if you keep it as is and you apply a multiply and do all the gymnastics that you need to do, then it will all work out in the end. So I would say avoid simplifying it this early. All right, so now you have the inverse. It's time to, if it's time to get the answer. So basically, if you apply the inverse to this side, you would get the identity matrix. So you don't need to show that unless the question tells you straight up, say, okay, show that A inverse times A equal identity, then don't do anything. Right? So unless that is the case, don't do anything to this side. But to this side now, says A inverse multiplied by, call this matrix, so this so-called matrix A, call this matrix B, and then call this matrix X for argument's sake. Right? As some people say, call this X. All right, let me call this X and then call this B. Yeah, I think I prefer that way. Call this B. All right. So we have the multiply now. And of course, the order matters. They want to have A inverse multiplied by B, right? So A inverse will have, so that's right. So A inverse multiplied by B is 3 over 10, 1 over 10, 2 over 10, 4 over 10, multiplied by R. Let me try and write that a little bit up. Multiplied by -1, 8. All right. So remember, we're talking about, I call it compatibility to just make sure that it can actually do the multiplication. We know that we can actually do it here, but just to remind you, so this is a 2 by 2 matrix, and this is a 2 by 1 matrix, because look at the number of rows times the number of columns. So this have 2 rows, so we say rows first, 2 rows, 1, 2, we put the 2 columns, 1, 2. This now have 2 rows, 1, 2, and then 1 column. And we'll look at the number of columns in the first matrix and make sure it match up with the number of rows in the next matrix. And once those two are the same, then it is fine. You can actually do the multiplication. The multiplication is well defined. You're not going to run into any issues. And then these two now tell you the kind of matrix that you're supposed to be getting. You're supposed to be getting a 2 by 1 matrix, when you finish this multiplication. So let me about that. All right, so we're going to do the multiplication now. So we did this the last time, and I told you guys, just think about 7, right? You go row, column, and that's all I need to remember. So this is 3/10 times -1 plus 1/10 times 8. And then you go again, row, column. So this now is 2/10 times -1. You know, you could have probably a hole here, but no problem. Plus 4/10 times 8. And then we try and simplify. Cool. So what I have here? We have, so it looks like I'm gonna need more space. Let me see if I can just draw a line here and just continue this up here. All right, so we're continuing this here. All right, so we have -3/10, right? And then we'll have plus 8/10. Then down here we have -2/10 plus, this is what, 32 now over 10. Right? So let us see what else we can do. We can simplify further. So this is coming down now, we're simplifying. So this is just simply 5/10, and 5/10 is just a half. So let us do that. Rather than, I know what I should be working, fine, I should be working. So 5/10. This now is just 30/10. All right. So to simplify, so the last step now, 5/10 is just a half, 30/10 is just 3, and we're done. So we are saying that the value for x, the unknown, because we have to solve that for the unknown, you know. This is saying the value for x is a half, and the value for y is 3. And that's it. And if you want to test it, which I would say test it, right? So let me see. And if you can copy and paste this thing here. So this is the first time I'm going to try this. Don't know if it will work. I don't even know what to do. Copy. Paste. All right, it's never quite work out. That's fine. There must be a way I can copy and paste it, but it don't look like it will work out today. Fine. So I'm gonna just test that these are correct by inputting it in the original equation. Of course, it's for teaching purposes, right? Because when you practice, you're supposed to be confident that you get the right answer. So this is 4x minus
Sir?
y. Yeah.
Excuse me, I kind of lost me here. Or you get 5/10 and 30/10 here.
How far back I need to go?
All right. Right at the bottom, but before you get the answer, where x is a half and y is 3. Where you divide it, yeah, how you get 5/10 and 30/10?
It is, you
I
saw this?
understand it. Yes.
Yeah, that's it. So minus 3 plus 8 is 5, and it's over the same distance.
Oh, sorry, I never do that. Okay, okay.
Okay.
Okay, sir. I see where you're
All right.
coming from.
All
All
right.
right.
Good. At least you're paying attention, right? All right.
Okay.
So this is 4x minus y equal this one minus 1. And wait, let me check. Yeah, it's equal minus 1, and then minus 2x um, plus 3y equal 8. All right. And then we know that we got x equal a half and y equal 3. So we're just testing this. And we really just need one piece of the simultaneous equation to test this. So for substitute the half, substitute that, and we want to get minus 1. So let us see what we get. So this is 2. 4 over 2 is 2. Yep, we get minus 1. And if we feel like we, want to give ourselves extra work, we can do the next, the second equation. We can use that and give ourselves some extra work. So hoping to get 8. So of course, this gives you minus 1. This gives you 9, and we'll get 8. So yeah, so we're doing good. All right. So there is another question. I just working 2 questions, and I think 2 questions is enough, because this thing can get repetitive real quick. So what's the other question? No. All right, let's use this one. 5x plus 2y equal 3, and then 3x plus 4y equal 13. Lovely. So same situation, you have the matrix representation. Let's see if I can use this thing a little better now, the space a little better. All right, probably I just divide it up. So 5, 2, 3, 4, x, y, 3, 13. Lovely. So we just need to find the inverse of this matrix. So what do we do? Same thing. If I were to call it A, so we know that A inverse, and I'm just drilling this over and over. 1 over the determinant of A multiplied by the adjoint of A. And the determinant of A, in this case, 5 times 4 minus 3 times 2. So this is what, 20 minus 6, which is 14. So we'll get that down. Adjoint time now. Adjoint of A. We'll do the swap-a-do. So this becomes 4, 5. We apply some minus signs to our diagonal, and we're done. So we're saying that the inverse of inverse of A is just 1 over the determinant, which is 14. And then we'll have this matrix here. And of course, I'll say let's multiply it out. All right, let me save some space. So this is 4 over 14 minus 2 over 14 minus 3 over 14, 5 over 14. Lovely. All right. So we know that A inverse look too strong. A inverse multiplied by A is the identity matrix. So this P is gone. And now we have A inverse multiplied by B. So I'm calling this column matrix B, right? And of course, we call this column matrix to the unknowns x. So we're trying to solve or find x. X is equal to A inverse B, right? So once we work out A inverse B, A inverse times B, then we solve for the unknowns. So turns out, all right, x is equal to A inverse B. So we're saying, all right, A inverse 4 over 14 multiplied by 3 over, my bad, 313. I'll do some multiplication. Could probably hold here. Let us see if we can make it hold. So again, row, column. So we have 4 over 14 times 3 plus minus 2 over 14 times 13. So kind of tight, space kind of tight right here, but it's all right nonetheless. Here we have, again, row, column. So minus 3 over 14 times 3 plus 5 over 14 times 13. All right, let's imagine that a bracket is here. Eh? So, that was so hot. All right. So we'll just simplify now. This part is straightforward. So I have 12 over 14. And then, of course, this is negative here. So this is negative 26 over 14. And then this is my negative 9 over 14. And this is off. 65. So that's a 15. Yeah, carry the 1 and then get 65. Yeah. So 65 over 14. Oh, good. All right. Brackets. Having a challenge with this bracket thing. So we'll simplify now. This becomes what that? Negative 14 over 14. This is 56. Or this is supposed to be a 14. This is 56 over 14. 56 over 14. Lovely. Now the question is, so we know for sure that this is negative 1. There's some testing for this thing, I know. So that probably is a 4, 4, 16. So that's probably 4 times. So 4, 4, 16, carry the 1, you get 56. So this is 4. Good. And that is your final answer. So I have x. Let's say if you can make it official. X is equal to minus 1, y equal to 4. We can do a quick check right here. So we can mentally check it. So if x is minus 1, we get minus 5 here. And if y is 4, 2, 4 is 8. So we have minus 5 plus 8 So we'll get 3. So we're good. If you want to get yourself, you know, more work for do, if you got to test it, you know, you can go right ahead. X equal -1. 3 times -1 is -3. And then 4, 4 is 16. -3 plus 16 is 13. So good little, you know, mental gymnastics. Good. So we did 2 questions. Let me see if there's any other simultaneous equation question we can do with the matrices. That is interesting. You know, everything is basically the same, really. So yeah, I think that's it. What I'll do, give you guys a break, and then we'll look at what else we can do. Yeah, if you have any questions at this time, you can ask, right? And I'll see what I can answer it for you. Any questions? All right. So no questions, no problem. So we'll just pause right here, and I'll see what other thing we can do. What other topic we can look at? Cool.